Hello, I'm Graham Lewis, and in this short video we're going to discuss this interesting rational function here. And the big question is, this has wholes and it also has vertical asymptotes, but what's happening at x equals 2? This is quite interesting. So the first thing we want to do to look for the restrictions is to factor this beast. So if we look at the numerator, the top of the fraction there, we can see we can take a 3x out as a factor, which leaves me with an x minus 2. And on the bottom there, I can take out a x, leaving me with an x squared minus 4x plus 4. Of course, once we've done that, we can now work on the x squared minus 4x plus 4 and factor further. So let's go ahead and do that. So we've got 3x over x, x minus 2, and then on the bottom, factoring this out, we've got an x minus 2 times another x minus 2, or an x minus 2 squared if you'd rather. Okay, so we've got some restrictions. Clearly x can't equal 0. When I put 0 into this function, I'm going to get 0 divided by 0, which is undefined. Clearly I also can't put 2 into this function. When I put 2 in, I also get 0 over 0, which is undefined. Now, the thing is, we can cancel the x's. So if I cancel the x's here, we can see that we've got a removable discontinuity, or a hole. I like the word removable discontinuity though, because it removes it completely. So I'm saying this function is equivalent to x minus 2 over x minus 2 times the 3 on the top, because I can remove the x. I can also remove the x minus 2's here. So I get a 3 on the top, and on the bottom I get an x minus 2. So we know that at x equals 0, I have a removable discontinuity, because as I was saying to one of my classes today, it's like a naughty point, isn't it? So basically, this function, this complicated function, behaves the same as 3 over x minus 2, apart from at the naughty point x equals 0, because it gives me 0 over 0. But otherwise, if I put 5 in, it behaves like 3 over x minus 2. I don't need to have the complicated expression. So x equals 0 is a removable discontinuity because I can remove it. But the question is, we cancelled one of the x minus 2. So is x equals 2, is it a discontinuity in terms of is it a vertical asymptote? I'll write VA. Or is it a hole, a removable discontinuity, or a point discontinuity? Which one is it? What do you think? Okay, hopefully you've had a think about that. And it actually is a vertical asymptote. And the reason is we have not been able to remove it completely. We were able to remove one of the factors, but not over all of it. So thinking of the word removable discontinuity really helps. So x equals 2 is in fact a vertical asymptote. So now let's go ahead and we can sketch this. So if we sketch it without technology, I know this is from the parent graph 1 over x, it's moved 2 to the right, and it's been vertically stretched by 3. And I know it has a vertical asymptote at 2 and a removable discontinuity at x equals 0. So it's going to look like this for that part. If I put x equals 0 in, I get 3 over minus 2, just putting x equals 0 in. I get y is minus 3 over 2. So I know at y equals minus 3 over 2 when x equals 0, I have a removable discontinuity, or a hole, or a point discontinuity. And there we have it. So that's what that function looks like, and you can check that in a package such as fxgraph, which will show removable discontinuities. So thank you very much for watching. I hope that helped with this kind of juicy problem. Is it a hole or is it a vertical asymptote? And if you enjoyed it, please watch some of my other videos.